Good evening, students. In the last video, we have seen up to the Darcy-Weisbach formula that they used to calculate the loss of head due to friction. Just remember the thing that in the flow through the pipe concept, we have to calculate the types of losses while the fluid is flowing through the pipe. So there are two types of losses: major loss and minor loss. Now, in the last slide, we have seen that the Darcy-Weisbach formula is used to calculate the loss of head, that is loss of energy due to friction, and the symbol used to denote that loss of head due to friction is HF, and the formula is 4FL V square upon 2GD. Now, I just have to explain one thing, that in the slide I have written that F is equal to coefficient of friction. Now, just remember, if in the exam, then in the given numerical, if the value of friction factor is given, then it is the value of 4F, that is coefficient of friction multiplied by 4. And if it is in the numerical, if the value of only coefficient of friction is mentioned, then we have to use the same formula 4FL square upon 2GD. But remember, if the value of friction factor is given, then we have to put the given value as 4F is equal to, otherwise your numerical will go wrong if you multiply the friction factor again by 4. So that concept we will again briefly see while solving the numerical. Now this is the formula, and the friction coefficient of friction is a function of Reynolds number, and if it is a laminar flow, the formula is 16 upon Re, and if the turbulent flow, then 0.079 upon Re raised to 0.5, that is 1 by 4. This is the formula if the flow is turbulent. Now just see a small numerical. This type of numerical are not asked in the exam. This is just to explain you the concept how to calculate the loss of head due to friction. In a pipe of diameter 350 mm and length 75 meter, a water is flowing at a velocity of 2.8 meter per second. Find the head loss due to friction using Darcy-Weisbach formula and Chase's formula. Now assume kinematic viscosity of water as 0.0212 stoke. Now don't have to go for the Chase's formula, just we have to calculate the loss of head due to friction by the Darcy-Weisbach formula. So what is given in the numerical? The diameter of the pipe is 350 mm, length is 75 meter. Now just remember, we have to convert all the given data into meter form. Then velocity is given 2.8 meter per second, and kinematic viscosity is given. Kinematic viscosity denoted by nu, which is nothing but mu upon rho, that is dynamic viscosity upon density. Now just see, we have in the here written the given formula, and the kinematic viscosity is converted into meter square per second. We have seen this unit conversion in the module number 1 also. Now just simply write the formula 4FL V square upon 2GD. Now what is unknown here in this formula? L is given, V is given, D is given, so only F is unknown. So F is coefficient of friction, and we have to first identify which type of flow it is, that whether it's a laminar flow or turbulent flow. Then we have to choose which formula we have to write. Then Reynolds number is nothing but rho Vd upon mu. Now rho Vd upon mu is a Reynolds number formula, but rho upon mu is nothing but 1 upon kinematic viscosity. So we have written the formula in the form of kinematic viscosity, which is given. Now put in the formula, we get the answer of Reynolds number as 8.167 into 10 raised to 5. So this value is greater than 2000. So we have to go for the turbulent flow formula, and the formula is written, and the answer for F is 0.00263. Now just for the reminder, for the sake of your information, I'm just telling you this value of F is given in the numerical. We don't have to calculate this value in the actual our university exam numericals. Now here if you see, the value of F comes in the answer of 0.002 form, but whenever in the numerical, if the value of F or a 4F, whatever it is given, it is in the only 0.0 form, then it's a 4F, remember. And if the value of F is given as 0.00 like something value, so it is only F given. So based on that, we have to change our formula. Then just put the values in the that HF formula, and we will get the answer as 0.9 meter. So loss of head due to friction is nothing but 0. Now nextly we have to see in the minor types of minor losses. The major losses due to friction. Now what are the minor losses? Now minor losses, as I have told previously, these are 10 to 20% in the total loss. Now first loss is loss of head due to sudden enlargement. Then second is loss of head due to sudden contraction, loss of head due to obstruction in the pipe, loss of head at the entrance of the pipe, at the exit of the pipe, due to bend in the pipe, and the various pipe fittings. Now one by one we'll see. Now just remember that minor losses formulas are also directly we have to take. We don't have to derive that. It is clearly mentioned in the syllabus that we have to directly take the formula. So as I have provided you firstly the list of formulas, so just go through that PDF. If you have joined the Google Classroom, then I have shared that formula list, that all module number 1 to module number 6, how many types of numericals are there and what are the steps on the formulas to solve that numerical. Just refer that. In that I have written all the formulas. In the slide also I have written all the formulas. So you have to just remember the formula, and while solving the numerical how to use it, that I will tell you. Now the first, loss of head due to sudden enlargement. If you see the diagram, initially the diameter of the pipe is d1, the velocity v1, pressure p1, area a1, and suddenly the diameter of the pipe is increased. So what happens because of that? If you just see, suddenly because of the rise in diameter, the space which is remaining at the entrance, that forms ADs of that fluid. So because of that fluid, some loss of the head is there, and that loss is nothing but the loss of head due to sudden enlargement. Now how to calculate this loss? So there is a simple formula. Now just remember here, h is the small h is the symbol we are using to calculate the head. Now if it is HF, we are saying it as loss of head due to friction. Now while calculating minor losses, just take the initial alphabet of the loss and write it in the small form in that H. So that will be the symbol for the minor losses. For example, loss of head due to sudden enlargement. So enlargement initial alphabet is E. So we are using the symbol for sudden enlargement as HE. So if we are writing HE, then it is loss of head due to sudden enlargement. So the formula is V1 minus V2 bracket square. Remember, it is not inside square, v1 minus v2 bracket square upon 2g. If you just simplify it, the answer is in the meter. So all the answers which we are getting, that are in the meters only. Now if it is in between the pipe, then how to use it, that I will tell you as the type of solving the numerical. Then the second is loss of head due to sudden contraction. Now if you just refer the diagram, initially the diameter of the pipe is large and suddenly it is decreased. So because of that, like a orifice meter or venturi meter, the vena contracta is formed, and that vena contracta, you are knowing that it's a whenever the diameter of that the is smallest diameter occurs, that is vena contracta, and it is denoted by coefficient of contraction, which is the value is less than 1. Now what is the formula to calculate the loss of head due to contraction? So as we have seen, H is the symbol for head, and as it is a contraction, so we are taking C from that. So HC is equal to V2 square minus V2 square upon 2G into bracket 1 upon CC minus 1 bracket square. Now remember, initially the velocity is v1, after the velocity is v2. So remember, whenever there is a sudden contraction, so we have to take the right side value, that is which is the last value, the last notation we have to take. Means suppose if initially this is second pipe and previously one more pipe is there, and if the initial velocity is v2 and after it is v3, so formula changes to v3 square upon 2g into bracket 1 upon cc minus 1 bracket square. Now we have to take the value of cc as 0.62. So if you put the value of cc as a 0.62, then we will get the final formula as hc is equal to 0.5 v2 square upon 2g. So this is a very simple formula. For enlargement, we have v2 square v1 minus v2 bracket square upon 2g, and for hc 0.5 v2 square upon 2g. Then lastly, these are all formulas I have collected here. Loss of head due to sudden at the entrance of the pipe, same formula. Now here I have not mentioned whether it's a v2 or v1, because where the entrance of the pipe there, what is the notation at that place, that we have to use that velocity. And if you see the entrance, so for that inlet is symbol used, and that's why HI, that is loss of head at entrance. So hi is equal to 0.5 v square upon 2g. Same as for the exit of the pipe, that is outlet, so symbol used is ho v square upon 2g. Then loss of head due to bend, the formula is just make a correction here, it is hb, so k into v square upon 2g. Now what is k? It's a coefficient of bend and the value of it is given in the numerical, so you don't have to worry. And remember, if anything value of k is not given in the numerical, so you have to assume the value as 0.5. Now please, while listening this video, just take a pen and note the important thing which I'm telling you, because visually we are not there, so it's difficult to understand for you, but I'm making as simple as possible for you. And last is loss of head in the various pipe fitting. Now what are various pipe fitting? If we are placing something wall in between the pipes, if we are joining the two pipes by coupling, if anything flow measuring device or any pipe fitting which are using in this, so because of that some loss is there, and the same formula we are using, k v square upon 2g. So these are all the types of minor losses. So in the next part, we have to see the different arrangements of the fluid flowing through the pipe. Now there are two types of arrangement we have to see. The first one is the flow through the pipe in series, which is also known as a compound pipe, or the flow through the parallel pipes. Now when we can say the pipes are connected in series, so it's a very simple concept as you look at into the diagram. When the pipes are connected end to end, that is in the series, which is having different diameter, lengths, anything, but they are connected end to end between the two reservoirs, then we can say the pipes are connected in series. Now as you look at in the diagram, you will see, just remember a simple concept that in the exam or in the numericals you have to calculate the major loss. So remember how much is the count of the pipe, that much number of major losses are present. That means for the first pipe, the first loss of head due to friction is different, for the second it is different, for third it is different. So in the diagram we can see there are two reservoirs, and we have to carry the water from reservoir 1 to reservoir 2, and that h is mentioned, that is the total head due to the losses. And the first pipe having diameter d1, length L1, friction factor F1. Then for the similarly for the second and third pipe. Now whenever the pipes are connected in series, so just remember the pipes are connected whenever you are connecting the pipes in series. So pipe 1 having area A1, velocity V1, pipe 2 is having area A2, velocity V2, pipe 3 is having velocity V3 and area A3. So we can write the continuity equation as you can see in the next PPT, that Q is equal to A1 V1 equal to A2 V2 equal to A2 V3. That means, just note it down, when the pipes are connected in series, the discharge remains constant. The discharge remains constant. The discharge will not change. So that is the important thing to remember. Now as you see in the next second diagram, it is clearly written there are 1 2 3 pipes, but the discharge Q1, Q2, Q3 is equal. So the total loss is nothing but loss of head due to friction in the first pipe, second pipe and third pipe. Here we have not considered the minor losses, we are counting only major losses. So if you just see, these are the simple formulas which I have written. As the friction factor for the pipe is same, that means not the loss of head due to friction is same, but the friction factor, the value of 4f, that is coefficient of friction f, that is same when the pipes are connected in series. So we can take it common from the formulas, and it is, if it is get common, so it is simply the formula which you have seen, 4f upon 2g L1 V1 square upon d1 plus L2 V2 square upon d2. Now nextly see, whenever this is the arrangement in which we have to consider the major losses also and minor losses also. These types of numericals are asked in the exam, in which this such types of arrangement is given to you, and the pipe diameter, length, the friction factor is given, and you have to calculate either the discharge or the head. So in such cases just simply remember, for the major losses, this is the bookish part which I have explained to you, but there is a one simple method which I follow, which I have explained in the next slide. what book follows? They follows whenever we have to count the major and minor loss, so they are writing it for individual pipe. So for the individual pipe it is quite difficult. So what I can do is, just see, this is the arrangement given to you in the exam, which I with the method which I follows is this, that I can write the, just wait, before that I just like to explain one thing. There are two types of numerical asked in the exam. There are two types of numerical asked in the exam. First is the discharge is given and we have to calculate the head, and another is the H is given and we have to calculate the discharge. So remember a simple step, that when we have to when the discharge is given and we have to calculate the head, so I have just modified the formula to make it very simple to you. So just look at it. Whenever the discharge is given, so this is the normal step which we follow whenever the 3 pipes are given. So we will write the formula for it, and just I have explained everything here. 4F1 is the friction factor, 4F is the coefficient of friction. Then if the discharge through the pipe is given, then write the formula for H as it is, that 4FL L1 square upon 2GD1 plus 4F2 L2 V2 square upon 2GD2 and so on. And instead of V1, just put the value of in the form of Q, because the discharge is same, and we can replace the value of Q by V by Q, that is V1 by Q, V2 by Q. How it is? So just see, as Q is equal to A1, V1 equal to A2, V2, therefore V1 is equal to Q upon A1 and V2 is equal to Q upon A2. So V1 is equal to Q upon pi by 4 D1 square and V2 is equal to Q upon pi by 4 D2 square. Now just make the arrangement and just put this value of V1 and V2 in this equation, and after putting all the constant values, that is except 4F, put the value of pi as 3.142 and G as 9.1. So we will get this formula, 4F1L1 Q square upon 12.1 D1 raised to 5. So it's very simple when the discharge is given and you have to calculate the head. So just put the formula in this and you will get the answer easily, instead of following the previous steps, which is one type of numerical. Now this is the another step. Now this step which I follow to solve the numericals when the pipe is connected in series or any type of numerical, whenever you have to calculate the major and minor loss, so just remember the total head loss is nothing but the addition of major loss and minor loss. So this is the simple step which I follow, that the total loss is nothing but the addition of head loss due to major loss and minor losses. So if in the exam it is mentioned that neglect the minor loss, then in this formula just remember total head loss is equal to head loss due to major loss. Now write the formula as H is equal to HL1 plus HL2. Now HL1 is nothing but the major loss and HL2 is nothing but the minor loss. Now write all the major losses as first present in the given situation. Like if there are 3 pipes, then the 3 major losses will be there. If 2 pipes, then the 2 major loss will be there. So write the simple formula for the major loss. HL is equal to F1 L1 V1 square upon 2G D1 plus F2 L2 V2 square upon 2G D2 plus F3 V3 L3 VT square upon 2G D3. And after finding this major loss, that is HL1, then write the minor losses. Now how to identify these minor losses? Just look at into diagram. At the entrance, first the entrance loss is there, so write the formula for entrance loss. Then afterwards, if the diameter of the pipe is decreased, then write the formula for contraction loss. Then if the diameter is increased, then write the formula for expansion loss. And if anything wall is there, then write the formula for that. If bend is there, then write the formula for that. And at the last, the exit loss. So minor losses does not depend upon how many pipes are there. It just simply depends upon the situation given there. So such as separately calculate the major and minor loss and just add it so that you can easily find the answer. So this is the easiest method to solve the numerical. Now nextly, I have explained one numerical when the pipe is connected in series. So see the numerical, simple numerical, 3 pipes of diameter, and just remember whenever I am explaining this numerical, so just try to solve it by your own, so you will understand easily. Then 3 pipes of diameter 300 mm, 200 mm and 400 mm, and length 450 meter, 255 meter, and 315 meter respectively are connected in series, the difference in water surface level in two tanks is 18 meter. Determine the rate of flow of water if coefficient of frictions are 0.0075, 0.0078 and 0.0072 respectively, considering minor losses also and neglecting minor losses also. Now if you just look at into given data, it's a very simple numerical. Simply three pipes, the diameter and lengths are given, their respective coefficient of frictions are given. Now just look at, I'm focusing very much on the word coefficient of friction and friction factor. So whenever it is coefficient of friction given, so you have to use the formula that in the given data you have to write it as F is only given and we have to multiply it by 4. That is, we have to use 4 FL1 V1 square upon 2G. But if the friction factor is mentioned, so you have to write in the given data as 4F is given instead of F. Just please make a note of it. Then write all the given data for the three pipes. Now first draw a tentative diagram to solve these types of numericals so you can easily understood. Now here there is no diagram given, so that means only in the minor losses there is no bend, any wall is there. Just simply draw first a pipe having 450 diameter something. Now by the common sense you can just think that the L1 pipe, the pipe 1 is having 300 diameter, pipe 2 is having 200 diameter and pipe 3 is having 400 diameter. That means first pipe is bigger, then the diameter is decreased, then it is increased. So such as draw the arrangement first. Here I have not drawn, but you draw. It's very easy to find the minor losses. Now after drawing that diagram, again the difference of water level H is given 18 meter and the friction factor for all the values. And what we have to find? We have to find the flow of water, that is we have to find the discharge. So just see, this is the bookish answer, but you just solve the step which I have explained to you. So very first thing you have to just see, that is in the major loss we have 4F1 L1 V1 square upon 2G D1, but we don't have the value of V. Velocity is not given and also discharge is not given. Then how to solve it? So as the step is mentioned, the A1 V1 equal to A2 V2 equal to A3 V3. Write the continuity equation as, and convert the velocity, any velocity, that is we have to just convert all the formulas in the form of V1 so that we can find any one velocity, and by that A1 V1 you can find the discharge. So H is already given, so here the formula is written, H is equal to, now they have combined the major and minor losses. You don't need to do that, or whenever the value of H is given, so you can write in this way also. So the formula is converted into V1. How it is? So V2 is equal to A1 V1 upon A2. So they will get the relation as V1 is equal to 2.25 times V1. Then also use the same relation, that is A1 V1 equal to A3 V3, and convert V3 in the form of V1. So just put this value of V2 and V3 in the formula whenever the V2 and V3 is there. So the all formula will get converted into V1 form. Now just the V1 is unknown. Now find the value of V1. Once you calculate the value of V1, so just use the formula Q is equal to A1 V1 and find the discharge. So the numerical is very easy, but the steps you have to remember. For this, please just see the formula list which I have shared to you already. You will easily understood. Also, I will find the next method to solve the more numericals. Here just I have explained you the one numerical for so that you can understood how which types of numericals are asked in the exam. Now the next arrangement is when the pipes are connected in parallel, or we can also say it as equivalent pipe. So in this diagram you can see, when you can say the pipes are connected in parallel, so when the main pipe which divides into two or more branches as shown in the diagram and again join together downstream to form a single pipe, then the branch pipes are said to be connected in the parallel. The discharge through the main is increased by connecting pipes in parallel. So the discharge is not same through the all pipes. So you can see the formula written over there, that Q total is equal to addition of all the pipes. So means if the 4 pipes are there, then it is q1 q2 plus q3 plus q4. Now but there is a little bit friction factor change here, that is the head loss due to friction is same for all the pipes, so you don't need to calculate individually if it is given for only one pipe. So in the previously series pipes in series, the discharge remains same, and in the when the pipes are connected in parallel, the losses remains the same. So when the pipes are connected in parallel, the discharge is addition of all the pipes discharge, and the loss of head of the branch 1 pipe is equal to loss of head for the pipe branch 2. So just we have to write the formula as 4 f1 l1 v1 square upon 2 gd1 equal to 4 f2 l2 v2 square upon 2 gd2. If you cancel out, because if the friction factor is same and the 2g will get cancelled, so remaining is only l1 v1 square upon d1 equal to l2 v2 square upon d2. So this, just see this arrangement, and the numericals are very easy. The numerical, in this numerical only the one discharge is given and you have to calculate the two different discharges. So just see one numerical for the example. The main pipe divides into two parallel pipes which again forms one pipe as shown in the figure. So the diagram is given. Then first parallel pipe, the first pipe dimensions are given. Length is 1000 meter, diameter is 0.8 meter. For the second parallel pipe, the length is 1000 meter and diameter is 0.6 meter. Now the coefficient of friction for each parallel pipe is 0.005. That means F1 is equal to F2 already given. Now if the total rate of flow in the main is 2 meter cube per second, find the rate of flow in each parallel pipe. That means the main total discharge is given to you, and this discharge is divided into two pipes, so you have to calculate the discharge for each individual pipe. So first write down the given data. L1 1000 meter, all the things are already converted into meters, so don't need to convert. L1 is 1000 meter, D1 is 0.8 meter, L2 is 1000 meter, D2 is 0.6 meter, Q is 2 meter cube per second, total discharge is given, and coefficient of friction F1 equal to F2 equal to 0.005. So the steps to solve the pipes connected in parallel is, first write down the main discharge formula, that Q is equal to how many pipes. So Q, here two pipes are there, so Q is equal to Q1 plus Q2. Now the loss of head due to friction is same, so write the formula for that. HF is equal to 4 F1 L1 V1 square upon 2 GD1 equal to 4 F2 L2 V2 square upon 2 GD2. Now as you see the given data, the length of both the pipes are same. That means L1 and L2 get cancelled. The friction factor is also same, so 4F1 4F2 will get also cancelled, and 2G is constant, so that will also get cancelled. So what is remaining only? So V1 square upon D1 equal to V2 square upon D2. Now the diameter D1 and D2 is given, so put into that this relation and form one equation of V1 in the form of V2. So if you just simplify, you will get V1 equal to 1.15 V2. Now what is next step? Just write down the formula for Q1 and Q2. The formula for Q1 is pi by A1 into V1, and what is A1? Pi by 4 D1 square. So pi by 4 D1 square V1, we will get Q1 is equal to something V2, and similarly write the formula for Q2 as pi by 4 D2 square into V2. You will get the relation in the form of V2. Now firstly, when you are calculating Q1, so you will get in the form of V1, we have to resubstitute the relation for V1 and V2. So we will get the relation for Q1 and Q2 in the form of V2. Now just put both the equations in the main first equation, that is Q is equal to Q1 plus Q2. The main discharge is given to you. Now just simplify and find the answer V2. Once you find the answer V2, just resubstitute it at that relation, you will get V1 also. And now just using Q is equal to A1 V1, find the discharge for the first pipe. Similarly, you can use Q2 is equal to A2 V2 and find the another discharge also, or we can use that relation as Q2 is equal to Q minus Q1. So in the next video, I will try to solve the more numericals based on this. Thank you.